In section 1.3, we're going to talk about linear functions, slope, and applications on page 90 of your textbook. A function is a linear function if it can be written as f of x is equal to mx plus b, which is the same as y is equal to mx plus b. What we've been working with before is when the value of m is a number and when the value of b is a number. So it would be something like y is equal to 3x plus 2. Those were the kind of problems that you've been graphing. So in algebra, we're going to let that m stand for the coefficient of the x value, whatever that m is. It could be any real number. And the b value is a number that's all by itself. It doesn't have a variable with it. So the m and b are called constants, or they're actually just numbers. M is the coefficient of x, and b is the number that follows that variable, and that's on the same side with the letter of x. So if we look at f of x is equal to x plus 1, the value for that equation is m is equal to 1 because it's the coefficient of x, and b is a positive 1 because that's the number that's all by itself. So if you look at the examples down below here, try to see if you can figure out what the values of m and b are. You might want to pause the video just a few minutes and see if you can work it out on your own and start it up when you're ready again. Here are the problems that you just worked. On problem A, we look at what the coefficient of the x is. It's a negative 3. That's the value that m is. And the value of b is just the number all by itself, which is a negative 1. On B, the coefficient of the x is 2, so m is equal to 2, and the number is also a negative 1 for b. For problem C, the number that is in front of the x is the value of 1, so m is equal to 1. There isn't a value of b there, so the value of b is equal to 0. Anything added to 0 is just equal to itself, so the value of b for problem C will be a 0. If you want to pause the video right now, I'd suggest opening your textbook to page 90. We're going to talk about linear functions again, and remember those are ones that have degree 1. So the exponent for the x and the y are both going to be of degree 1, or have an exponent of 1. On page 90, the first 4 that are across the top at the bottom of the page are all examples of linear functions. Linear functions graph as a straight line. The ones that are nonlinear functions are the ones on the bottom, and you can see that the first one has an x to the second power. On the second one, it has ax in the denominator. The third one has a square root of x plus 4, and then the fourth one again has the x plus 3, all of that to the second power. So those are the differences on graphing between the ones with linear equations and nonlinear. You can see how much easier the one with linear functions are because 2 points always determine a straight line. In order to get those curves correctly on the ones that are nonlinear functions, it would take plotting a whole lot of points or understanding what each one of those was going to graph like before you even did it. The value of m that we've been discussing in the previous equations is actually called the slope of a line. And we're all familiar with what really a slope is. If we think about going skiing and we're at the top of a hill and we are looking down, we go, oh, that's a really steep hill. And we're thinking about it as going down. If we're running and we're at the bottom of a hill and look at the top of the hill, we're thinking, well, that's a really steep slope that we have to run up. So we're having the concept of going down a hill or up a hill, or if we're thinking about walking across a room, it's hopefully on the level and it doesn't either go up or down. If we're thinking about in terms of handicap ramps and you're an engineer, what you need to know is what is the allowable slope. And if we look at a handicap ramp in various buildings, what they must achieve is a certain amount that they go up for a particular distance. So that's why a lot of times you see those long ramps going into a building. And in fact, if you were going to do a concept application, a handicap access ramp might be a good topic for you to investigate and determine what actually that slope is. So what we're going to do here is actually put a number with a slope. So we could discuss the various things, but besides just saying that, oh, that's a steep hill, it has a steep slope going downhill, we could discuss and compare two of them if we know what the slope of that hill is. And the slope is going to be defined as the rise divided by the run. So the rise means how much does it go up or down, and the run means how much does it go either left or right in a horizontal distance. So if we put it in terms of the letters that we've been used to using, it's the change in y, how much does it go up or down, divided by the change in x, how much does it go to the left or to the right. There are two equations which are identical for this. It's y2 minus y1 divided by x2 minus x1, or we can also use y1 minus y2 and divided by x sub 1 minus x sub 2. If you look at these, the ordered pairs must be over the mate in the calculations. You could have gotten by with it when we were doing the Pythagorean theorem of not actually having them in the correct order. You would have gotten the same values actually, but here we have to have the ordered pairs in the correct order above their mates. So we're going to try to take a look at some of these problems and kind of get a feel for what the slope is. If we know what a slope is and we have a graph, and if we're at one point on the line, we have to be at a point on the line to get to another point on the line that has the same slope, and that slope is m, we're going to express it as a fraction of y divided by x. A positive y means you go up. A negative y means you go down. A positive x means you go right, and a negative x means you go left. This is very intuitive because we always think of going up as being positive, going down as being negative, and we've been used to graphing on a single line where x going to the right was a positive number and x going to the left was a negative number. So let's take a slope of m is equal to 2. If we express that as a fraction, it's 2 divided by 1. So if we're at a point on the graph for a slope of 2 means that we would count straight up 2 units and then we would move right 1 unit. That would be a point on the same line. To get to the next one, we would do the same thing. From where we were at, we would go up 2 and right 1. If we had a slope of negative 2 and we express as a fraction, we could express it as negative 2 divided by 1 or 2 divided by negative 1. Both of them will give us exactly the same result. So if we have our slope expressed as negative 2 divided by 1 and we're at a point on the line, we would go down, straight down 2 units, and then we would go right 1 unit. And then we could keep doing that and get other points on the line. If our slope was 2 divided by negative 1 expressed that way, we would go up 2 units and left 1 unit. It just depends on which way we were going up or down the line. They would all be points on the line, just different directions from the point that we started at. We're going to take a look at a graph of f of x is equal to x plus 1. We know from what we've been doing previously that the coefficient of the x is 1, and that is actually what the slope of that line is. So I'll let you look at the t-bar chart that we have right there, the values for x and y, and determine that those are correct. If you look at those, they're actually a difference of 1 between each one of the consecutive pair of x's, and also a difference of 1 divided by the consecutive y's. So if we took the change in y's between the first two pairs, it's 1, and between the first two pairs of x's, it's also 1. We could get our slope that way. The other way that we can do it is like you're going to do in the test this next week. You're going to pick 2 points, so we'll just pick the first 2, and we're going to call one x sub 1, y sub 1, and the second one x sub 2, y sub 2. Over on the right, you can see what their values are for each one of them, and we're going to pick the formula y2 minus y1 divided by x2 minus x1. Filling in the blanks with the numbers there, we get 0 minus a minus 1, which is positive 1, and on the bottom, minus 1 minus a minus 2, which is minus 1 plus 2 is equal to 1. So we get a slope of 1. Here's our graph of that line, and if you start at the point minus 2 minus 1, from every one you can see that you can go up 1 and right 1 every unit to get to the next point.